breaking free now wherever we go.
Again at the DevOps Talks conference, and I'm here with Lindsay Homewood. Lindsay, could you introduce yourself to everyone?
Yeah, so my name's Lindsay Homewood. I'm an engineering manager working over at Envato, which is one of the most successful Australian startups that you've never heard of.
Oh, excellent,
Yeah.
excellent. Speaking of Australia, it's my understanding that you were one of the first to bring the DevOps Days conference to Australia.
Yeah, that's right. I ended up running the second ever DevOps Days in the world back in 2010, but just before the first one that kicked off in Silicon Valley. So
awesome.
I was at the 2009 one in Ghent, and then I thought, oh, this is actually a pretty cool idea. Wonder if we could do something like that here in Australia, and yeah, we did it, and the community's been growing ever since.
Yeah, so you've been part of helping grow that community basically worldwide since 2009.
Yeah, that's right. Sort of the Australian linchpin down here.
Right, absolutely, absolutely. And is this your first time at a DevOps Talks conference?
It is actually, yeah. I've been meaning to get to one for the last little while, but Igor very kindly invited me this time, and I'm super stoked to be here.
Excellent, excellent. And we're really excited to hear your talk, which is coming up just in a moment here.
Yeah. Yeah, no nerves.
No nerves at all. It's great. It's great. But how's your morning been so far here?
It's been pretty great. Really great collection of speakers, really interesting insights. Particularly from you. I love hearing different people's takes on what DevOps, what the journey actually means to them, and what's actually important, what isn't.
Great. And can you give us a brief preview of your talk?
No, actually.
All right, very good.
I'm keeping it all under wraps.
Excellent, excellent. Well, thanks so much, Lindsay. It's great to speak with you.
Awesome. Thanks, Nathan.
All right.
All right, so mic on? Hello?
Not quite.
Yep. Okay. Well, hopefully everyone's had their afternoon coffee, so there's not too many people falling asleep, because I know it's hitting that afternoon kind of time, and it could be a long day at a conference, but the talks have been really good today, so hopefully you're still engaged and energized around DevOps and so forth. Today I'm sort of talking on is NoOps the future of DevOps? This title is a little bit clickbaity, I'll be honest. It's really looking at it's sort of zooming in a little bit more than some of the previous talks today, and looking at how does these sort of changes in things like serverless and higher level infrastructure patterns affect the ops role and so forth. So I'd just like to start just out of curiosity, a show of hands, who here kind of identifies themselves in kind of the operations space? So whether you're a sysadmin or SRE or any of that kind of thing. So, okay. So it's a pretty good mix, and it's probably about 50%. Quite often you do this kind of thing and it's a room full of ops people, but it's actually good to see that the audience is broadening a little bit. So I thought I'd start with a little bit about who I am and why I care about this. So as Nathan mentioned, I'm the DevOps platform lead at DigIO. We're a consulting firm. We work with a number of large organizations within Melbourne. So for most of my career, pretty much since I left uni, I've been in the ops space, for want of a better term. So I started probably as what would be considered a traditional systems administrator. I can remember some of my first tasks back in the day, how to put a new server into production involved going into the server room in our office, loading up a rack-mounted server into the back of my car, driving to the data center, putting it in a rack, DDing its disks off one of the production servers that was already there, renaming it and putting it into production. What could go wrong? But sort of from there, I was fortunate enough to be in a company that involved quite early into sort of more modern practices, so into things like configuration management and actually building servers repeatably rather than just cloning what was already there and all the problems that came with that. And then, of course, came along the cloud, or AWS was, very much the first contender in that space. And then moving to much more of infrastructure as code, and sort of some of the more concepts we've heard about earlier today around immutable servers and so forth, and things like that. Since then, I've also moved. I moved into more of a management role, leading a team, looking at how to best, I guess, improve that flow of value that comes from your IT infrastructure. And now as a consultant doing that and helping other organizations sort of achieve that. So I've got a strong interest in this space and where this is kind of heading for the ops community, I guess, as a greater whole. So I thought I'd start with some definitions though, because I am talking about a number of quite loaded terms, I guess. So DevOps, and by the way, these are my definitions. I'm not saying these are the only definitions, the best or anything like that. I'm just saying these are the ones I'm using for the purpose of this talk. So DevOps is really around the IT practices and processes that help enable the organizational value stream. So what does that mean? It basically means it's how, as an IT organization, we get shit done that's good for the company. Operations, I really define that as being anyone who is specialized in and has a dedicated role for sort of the concerns of the runtime part of the software and IT products. So that doesn't necessarily mean that they're a dedicated team, or it doesn't necessarily mean that there's a dedicated silo for that. It's more around the idea that there is a dedicated role. So someone whose main job is to be thinking about this. And no ops, I really see this as teams or organizations where that lack of dedicated role exists. So again, it's not to say that they don't do operations tasks. It's mainly to say that there is not someone who it's their primary job to do that. So if we look at the current trends in kind of IT infrastructure, and a lot of this has been touched on today already, but I've sort of got a chart there sort of showing what I kind of see as the 6 kind of major patterns that are out there at the moment. So on the left, we've got on-prem, as in physical data center, servers and so forth. We have to worry about everything. IaaS, which is kind of your traditional cloud kind of patterns, so EC2 or Google Cloud Engine, that kind of thing. And then we move into platforms, which might be something like Heroku. We've got container platforms before that, sorry. So container platforms being something like Kubernetes. And then we move into serverless, and then finally SaaS. SaaS is an interesting one because you might say, well, it's not really infrastructure, it's just something you buy. But I still see that as kind of another pattern because it's becoming more important and you still have to configure it normally. So I sort of see IaaS as one. I mean, you don't really hear about too many companies that are going, wow, we're about to build a new shiny data center anymore. It's really becoming a niche play. So obviously if you're Google or Facebook or someone like that, then yes, you probably are still building data centers or data halls as they have now. But for the 90% of cases, we're seeing a move towards cloud. Pretty much every company has a cloud strategy of some kind out there. And then on top of that, we're seeing containerization becoming more and more popular, as we've already seen in this conference, a number of times it's been mentioned. And Kubernetes is really becoming the kind of industry standard around how to do the orchestration of those containers. And we can see this, with all 3 cloud vendors having a Kubernetes play, and even Docker themselves, not quite abandoning their own orchestration, but Kubernetes is kind of becoming a first-class citizen for them as well. And then we're also seeing serverless and FaaS increasing. So again, we've seen a number of mentions of serverless, and this is really taking off, especially in the sort of the more greenfields or startup kind of space. But it's not just limited to that either. And then finally, as I kind of mentioned, we're seeing SaaS. And I almost say I haven't seen a new architecture come in the last couple of years which hasn't had some kind of SaaS component to it. So I guess the key message on there is that that sort of chart there, we're seeing a trend move towards the right. So we're seeing more abstraction away from the bare metal and the responsibility of running low-level services. So a couple examples of serverless architecture. As we saw with Graham's talk before as well, it's really not hard to spin these kind of things up anymore. We're really looking at a case where developers can do this in minutes or hours at worst case. So as a result, we're kind of seeing a number of what I'd say the traditional operations tasks are kind of in decline now. So physical servers, management of that, as I mentioned, obviously not really happening as much anymore. I will mention these are in decline. I'm not saying these don't happen, because I'm sure there's probably at least half the room here who do manage physical servers, but I'm saying we're seeing it decrease, not increase. Configuration management as well. Even though I was saying that was kind of the first evolution from moving from a traditional sysadmin. I'd say now it's in decline because once again you move to containers, serverless, so forth, immutable infrastructure. You worry less about the actual configuration of those because you build it in as your part of your code to build the infrastructure. And again with security patching. So, you know, as John's talk at the start, it was very scary around the sense of the number of security patches that are not being applied. But rather than worrying about actually patching existing servers, we're seeing a more trend towards, well, let's just rebuild the infrastructure on demand so we don't have to worry about that as much. Backup and restore. Again, as we're utilizing more high-level services, you don't have to generally worry about, do I have to take backup? Because, well, the platform takes care of that for you. You may have to configure something, but again, the concern that you have to spend on this drops. And then finally, sort of bespoke and expensive CI/CD platforms. I've been a consultant for a few years now, and I'd say, you know, a number of years ago, half the projects we would get involved with was, okay, can you come in and please set up this CI/CD pipeline so we can have all the DevOps? But I'd say now we see a lot less of this because teams know how to do this themselves because, again, platforms are providing it a lot more. You know, a few clicks and you've got something up and running quite quickly. So that's it, right? Mission accomplished. You know, developers can create their own infrastructure. Job done, you know. So enjoy the last few years of being an operations engineer. Well, maybe not. So I'd say there's still a bunch of things that we need to, that are still within this remit of this role. So things like capacity planning, even though we're moving to a cloud with much more elastic environments, and sure, we don't have to do as long-term capacity planning, but it becomes much more real-time. So this can be anything from, say, a certain cloud provider doesn't have a certain type of instance available in Sydney when you need it. How do you manage that? Or thinking about other types of scenarios where you suddenly need to scale up quickly. And how do you, the services you rely on allow you to do that or don't? There could be service limits, for example. And then we've got SLO and SLA management. So I think as it was touched on in an earlier talk, I think it was Peter who mentioned this, is that as you depend on more services, those services become part of how you form your SLAs. So it's less like you're outsourcing your ops department and more they become an extension of that. And you have to very much take into account their SLAs when you're building your applications. So a number of times I get asked around, well, we want to run something on EC2 in Sydney and we need higher than 99.95 reliability. It's like, well, you can't do that because that's the SLA that Amazon provides you. Anything else and you're just gambling. Anything above that, rather. Performance and resilient engineering. Again, this is going to become more and more important because we're seeing a situation where the size of each service is decreasing, but the complexity of the actual apps that are composed by those services is not decreasing. So logically, it means we have more services running. So really it comes down to you've got more moving parts, so the reliability in that becomes a bigger concern. And it really comes down to, if you think about microservices, it can become a murder mystery quite quickly if you don't have good sort of performance and resilience engineering around it. Disaster recovery. There's kind of another one where, well, if you're relying on more providers, what happens when they break? What happens when a whole region goes down, for example? How do you respond to that? And that feeds into incident response as well, which is really around, okay, how do I build in continuous learning inside my organization? How do I ensure that the services I'm relying on and those organizations, how do I know that they're doing continuous learning as well? And we're not just seeing the same problems over and over again. And then finally, cost management, which is really around, well, as I move from infrastructure pattern to a different one, how does that affect what I'm paying? Because all these have different cost models. So we need to avoid things like bill shock and so forth. And this can also come down to not only the patterns I use, but what does my usage pattern looks like? For example, you know, AWS Lambda is really cheap when you're doing a low, it's not free if you're doing a low volume kind of thing. But what happens when you're suddenly doing a very high transactional application and do that in Lambda? it can get quite expensive quite quickly, and more expensive, say, than EC2 or something like that, depending on the circumstances, of course. But that's kind of what we need to know. So the other side you can look at it and go, well, why don't we just hire a bunch of full stack engineers? You know, it's quite a common term we're hearing, and everyone should be able to do everything. Well, yes, there are people out there who can do this, but they're extremely rare and generally pretty expensive. So if you're trying to think about how you're going to scale your organization, you're going to have a hard time trying to find people that have a really well-rounded knowledge across everything. And to be honest, the most common pattern I see with people who claim to be full-stack engineers is generally that they're good front-end and back-end developers. They're less likely to have good ops knowledge on top of that as well. So the more common pattern we kind of see, and I know it's a bit of a management buzzword, but is the T-shape engineer. So someone who is really strong in one or two areas, whether it's front-end or back-end development, or ops and back-end, or some other kind of combination, but has a wide range of the other areas, but is not an expert. And I think that's actually a good thing. I actually like the idea of T-shape engineers, because if you get a team that's made up of a bunch of these, but they're in different areas, then obviously they can learn off each other and everyone improves, which is a good thing. So I'd also say, when we're looking at platforms, it's not free when you move to the right. You are giving away something, and what you're really giving away is flexibility. So, they're great. They're very fast to get started with. You can spin up something in Heroku. You can get a full web app working in a very short period of time. But you find that most organizations outgrow that quite quickly because they end up fighting the solution. And I think it really comes down to size matters. So, if you're a 5-person startup, then yeah, you probably haven't needed a dedicated ops person for quite a while. And it's very much going to be the case. But on the other end of the scale, if you're a large bank, we've seen people from ANZ and Westpac and so forth talk today, I can't see them going completely serverless and not needing ops people or anything like that anytime soon. It's really a case of the complexity of your environment generally grows with the size of your organization. And you have to really think about and build your architecture based on that knowledge of what you're trading off. So, it's great to go fully serverless if you have full control over how your application works and how if you understand and build for those limitations that serverless requires you. And it's not to say those limitations are bad, it's just to say that you need to understand and build for them. So things like, no state and the fact they can't run for more than 5 minutes and so forth. So this is kind of my view of what I see as the future of the operations engineer. Probably number one, I see them as service experts. So it's really about knowing what is out there, all the possible options, and how best to utilize those. And I'll kind of dig into that one a little bit more in a minute. Platform engineering is probably the other part of it, which is really around not only once you decide on what level you want to build your infrastructure at and what services you want to utilize. So if you decide that platform as a service is the right level or a container engine. But platform engineering is really then taking that and adding on top of it the business assumptions or the internal shortcuts that you can take as an organization. So, and this can be at any level. So one example I have from one of my previous employers is that we were using PagerDuty, which is a SaaS product. But we added a platform of sorts on top of that, which was around using Terraform to take a bunch of shortcuts so that developers could very easily add monitoring to their app or alerting to their applications without having to know as much about PagerDuty as they otherwise would. But again, that's not something that can necessarily be abstracted away to all organizations because a lot of those shortcuts were internal to that particular organization. And that's where I sort of see platform engineering. Resilience engineering, which I touched on before, or chaos engineering is kind of the other common term for it. And it's really around building in that continuous learning around how you're testing your infrastructure and how you understand your services and how they break and how you'll survive that. And then performance engineering, which is kind of the happy side of resilience engineering almost. So it's like, okay, well, what happens when a whole bunch of new users show up? How do I scale with load? That sort of thing. And how do my underlying services respond to that? do I need to be aware of it ahead of time? Do I need to make sure that my service provider know that I'm expecting, 1 million more users next week? Data protection. So I touched on the fact that backups and restore are probably less of a concern for an ops engineer or in decline, but data protection is probably increasing. And this is really as a result, because we're more in the cloud, we're using higher level services, we're almost in a public environment by default. If you don't do something, if you don't ensure that your data is private, it can very easily become public. So I kind of say that as it's not really around making sure have you got a tape backup. It's about who else has your tape backups. And then finally, cost management, which I also touched on, which is really around understanding how the different cost models work and then how to architect for those. So, and again, this is why I come back to Lambda can be super cheap until you're using it at a certain point, and there's kind of a graph that crosses over between that and something like an EC2 costs, where it'll actually become cheaper to run an EC2 instance at a certain point and a certain number of transactions, which may or may not be worth the trade-off, but again, it is something you need to be aware of. So if I look at service experts, number one is around really knowing what options are out there. So it's around, okay, I know that I can build with all the different tools, whether it's AWS, Google, so forth. Different SaaS options are out there so that I don't have to reinvent the wheel, that kind of thing. But then it's also around, well, how do I glue these things together? And this is a really interesting one, because I think this is where sort of ops people having a knowledge of coding. I mean, this has already been a thing for a while with infrastructure for code and so infrastructure as code. But I think this is kind of becoming even more important when we start looking at this. Things like writing your own Lambda functions or other serverless type things to tie pieces of infrastructure together. And then really around how do they break as well? Because I don't think there's enough time spent on this, particularly in our kind of industry at the moment. I see a lot of infrastructure that kind of assumes a good day in the cloud, and that's not always the case. And then also, what does it mean when they do? So it's around, okay, well, if I suddenly lose a availability zone in Amazon, how do I respond to that? What does it mean for my application? And then what happens if I lose a region? Because I mean, we look at things like Amazon have had outages for S3. Google recently had an outage for their global load balancer. So how does your organization respond to that if you're mainly hosted in those kind of platforms? So really my final thoughts around this, do I need to find a new career if I'm an ops person? No. And by the way, we're hiring, so please come and chat to me. Do I need to keep embracing change though? Well, yes. And I'd say my key kind of tip around this is, stop building and running what can otherwise be provided by good SaaS. A number of organizations I still see running very manual CI/CD pipelines when they could offload a lot of that complexity and probably, take a whole team and deploy them on higher value tasks. And my final thought is really, so be an expert in what the business, how the business can get value from its IT investment, and I guarantee you'll have a job for life. Thank you.